All right, welcome everyone to our fireside chat recording about defining the Zero Trust Protect Surface with John Kindervag, Zero Trust Evangelist for Illumio, and also part of the CSA's executive steering group for our Zero Trust research team, and Shruti Kulkarni, who's the workstream lead for the data pillar and also the identity pillar, who's the lead author for this document. And so thank you both very much for taking your time to meet with us today. And this document is the first in a series of 5 that we're coming out with to elaborate the guidance for each one of the 5 steps in the methodology. And then along with that, we'll have companion implementation primer. So this one being the first step, let's provide a little bit of sort of background or context in terms of Zero Trust. Assuming most folks would be somewhat familiar with it, but just in case, maybe John, could you give us a little sort of thumbnail sketch of what is Zero Trust?
Yeah, I think the most important thing to understand is that it's a cybersecurity strategy. It's not a product, right? And what we do is we try to stop data breaches, make other cybersecurity attacks unsuccessful, and we do it by eliminating trust from digital systems, right? So trust is this human emotion. It's hard to define, hard to describe, but it got used as a word in cybersecurity early on. And when I was at Forrester Research working on what became Zero Trust, I realized it was the fundamental problem and that data breaches were caused by an exploitation of that trust model. So Zero Trust is that simple. You know, it's a strategy that can resonate up to the highest levels of any organization, but it's can be tactically implemented using off-the-shelf technologies at whatever state that they're in. And those two things, the strategy and the tactics, are purposefully decoupled from each other because I knew the strategy wouldn't or shouldn't change once we realize if it works, and we do now. But the tactics, the technology would always get better and better and better. And so you want to make sure that there's freedom to make the solutions, the architectures, everything work better and better over time. But ultimately, you want to have a strategy that resonates up to the highest levels. So, for example, Zero Trust has really been changed by the President of the United States issuing an executive order that essentially mandated that all U.S. federal government agencies adopt Zero Trust architectures. And this changed the incentive structure around Zero Trust. So by changing that incentives, it can empower everybody to do cybersecurity in a different but better way.
Excellent. And that sounds like it's increasingly relevant these days as, you know, with deeper inventorization, as more and more corporate assets are going out in the cloud and, you know, remote workforce, you know, there's less and less assets sort of inside the traditional castle, right? So
Absolutely, yeah.
That might have something to do with its increasing and continued popularity, right?
Absolutely.
And one of the other things I would note, for sort of from the CSA perspective, since we are the Cloud Security Alliance, which is, you know, most of our work does focus on cloud security, but in the case of Zero Trust, we made a conscious decision to broaden the scope, given that it is this holistic enterprise-wide security strategy, and that it necessarily does need to include cloud, on-prem, hybrid environments, and along with the mobile endpoints and user endpoints. And also that it's applicable to IoT, operational technology, and even extensible to physical security. So just want to make sure that the scope of our research in this space is broader than just cloud. And that comes up in some of the examples you'll see in this document that we'll probably be discussing here today. So let's talk a little bit about the 5-step process, John, some of the background. I know you developed this quite a while ago and been, you know, evangelizing it and maturing it based on, you know, real world experience, but also that it is reflected in the NSTAC report to the president when, you know, goes back, what 2 years ago now?
Yeah. So I started this process when I was at Forrester creating Zero Trust. And there was a time when I was the only person actually doing Zero Trust implementations. And I realized after a number of them that there were 5 things that every implementation had in common. And so I decided to codify that in a way that I could help other people have a map to guide them to the right way to do it, and they don't have to make the same mistakes I had. So the first step, of course, is the one we're talking about today: define your protect surface. That was originally called define your data because Zero Trust is very data centric, and we need to protect our data. Right back in the day when you and I started, we were doing information security. So we knew what to protect. But now we do cybersecurity. What's a cyber? Why should we protect it? So it becomes a little more squishy. So I
Mhm.
wanted to talk about, let's go back to not just using technology, but protecting something. And then people said to me, that's fine, but I also want to use this same methodology for protecting other things. We've talked about IoT. I've done a lot of IoT work. I want to use it in a data center for a server that isn't related to data. So that's where coming up with the concept of protect surface came. Instead of focusing on the attack surface, which is an outside in view, let's do an inside out, start with what we need to protect. And that gave me the concept of the protect surface, an inversion of the attack surface so that we can shrink the attack surface down orders of magnitude to something very small and easily known, and that's called the protect surface. So inside every protect surface, we have a single DAAS element, right? So
Mhm.
data, applications, assets, or services, and I think we'll talk about that more in a minute.
Yeah.
But we put it inside of that protect surface, and then we build out our zero trust environment one protect surface at a time. So in this way, zero trust becomes incremental. We're doing it one protect surface at a time. What I find, people try to go too big and do it all at once, and
Mhm.
that's where zero trust fails, because it's not designed to do that way. And no problem is solved by doing it all at one time. You break it down into manageable chunks. The
Mhm.
second thing zero trust becomes is iterative. We're doing it one after another, which you would do anyway, but it's talking about it in those terms that help people understand it. And then the exciting thing for me is that it makes it non-disruptive. The most you'll screw
Mhm.
up at any one time is one protect surface, and that's easily fixed. So you don't have to worry, will we break our network? Will we break our cloud? No, you won't, because you're doing only a small thing at any one time. And
Mhm.
then from then on out, when we do the steps 2 through 5, we're kind of deep diving into each protect surface. And then with step 5, we're actually also coming back and looking at the zero trust environment holistically. And, I got to collaborate with Shruti on this. She was a great lead for this work stream. Shruti, what were your thoughts when you first heard about this concept, and how did it resonate with you?
So my first thought was like, what does a protect surface mean in an organization? I mean, every organization defines their sensitive data or elements or assets to their organization context. So a protect surface could mean as small as a server, because it's an asset, or it could be as large as an operational technology system, like, for example, the LiDARs machines that we see in airports, that also could be a protect surface. And yes, that was very interesting for me to make it very applicable to the organizations that we are working, and very applicable to the business information systems that we have in place. So it's as we see it fit for our purpose in terms of defining the protect surface. So that's what I saw when we started working on this paper.
Just to continue on, I want to introduce each of the other 5 steps, because there'll be
Yeah.
recordings on each of them, but let's just kind of go through them so that you have this perspective. So step 2 is mapping the transaction flows. We're asking, how does the system work together as a system? And I learned this the hard way, working on a system where somebody pulled out a server because it was old, and it brought everything down. It brought this massive global network down. And of course, everybody blamed zero trust. But the reality was, somebody didn't know how the system worked. So I started doing this transaction flow mapping. And this has really been validated. The recent NSA information sheet on, leveraging the environment and network pillars of zero trust, they talk about mapping data flows, which is the same thing, right? Data flows, transaction flows, the same thing, looking at how the system works together as a system. And then once we do that, that's when we architect it. Because when I started, we had these massive reference architectures just to move packets around, and that was fine, but we didn't know what we were securing. Now we need to design from the inside out. So I like to say, and Shruti rightly pointed this out, every zero trust environment is tailor made or designed, or to use a British term, because Shruti's in London, bespoke for the protect surface that it's actually protecting.
Mhm.
So when you say, I bought this technology, what do I do with it? My first question is, what are you protecting? So once you understand that, it will be clear how you need to architect it. Then step 4 is to write policy. Everything is instantiated in policy in security. So I have a thing called the Kipling method model, or the Kipling method way of writing rules. And this is an homage to the writer Rudyard Kipling, who gave us the idea, or reinvented, I guess, really, the idea of who, what, when, where, why, and how, and put it in that order in a poem in 1902. And what I found is I traveled all over the world, and I needed a way to communicate how to write policy that crossed all cultures, all languages, and everybody in the world understands that. So who should have access via what application, to where is that resource or protect surface located? Why are we doing it? Some sort of metadata that gives us that information. And then how are we validating it? And we also have time, so when, but very people have time limited rules. And I want to encourage you all to think about limiting your rules so that they're turned off when the people aren't normally accessing it. Because if you've ever looked at attacker logs, you'll see they come in after your people have left from work. And so that's the 4th step. And then the 5th step is where we take all the telemetry. It's called monitor and maintain. We take all the telemetry from all of the protect surfaces that we have, and we analyze it, and we re-inject it back in the system so that we can make each protect surface stronger and stronger over time. And then the entire system becomes what's known as anti-fragile. So this is language that I adopted from the writer Taleb, who wrote Black Swan, but he also wrote a book called Anti-Fragile, where he talks about there are systems that are not just fragile and not just robust, but they get stronger and stronger under stress, under load. And his example is the human body. When you need to lose weight, get in shape, whatever, you put your body under stress. You ride your bike, you swim, you lift weights, you do yoga, whatever you do, you stress it out so that it adapts to the stress and gets stronger. And he gave me the language to use what I was trying to do in Zero Trust. So those 5 steps working together build a protect surface, and protect surfaces being added on one at a time in your journey, build your entire Zero Trust environment.
Excellent. Thank you, John. That's a really great summary. So go back to step 1 a little bit, where it's sort of collecting some of the initial data there about what are those assets in the organization that need to be protected, and sort of how do we group them together so that you don't have a sort of proliferation of, too many micro assets and like that, and things that would benefit from being looked at holistically. Maybe Shruti, do you want to share a little bit about the conversations we had and deliberations about that back and forth, and then discussions with John on that subject?
Yes, indeed. Because we talk about the protect surface, and it's not just data centric; it's also asset centric. So one of the key elements is actually discovering the data that is resident in your environment. And if we have an IoT or an OT kind of environment, we need to look at the assets as well. So we talked several times, or discussed over this to identify what is a really good practice to discover what is valuable to you in the environment. And some of the things that we came up with was, you can have automated systems. Like there are automated data discovery tools, so which we can use to acquire the data locations. Sometimes, you may not be able to use automated systems, like the structured data is located in databases, in which case you may have to go and speak to people, interview them, and try to get the location of those of that data. But as a kind of orthogonal to that is the location of assets. So asset can also be discovered with automated tools and manual ways, and then piecing all of them together along with the metadata and the services that support them and the assets that they reside on. So this was a really very interesting piece of conversation, because it tells us that the automation is not the only way. We need to look at various other out-of-the-box ways to locate what is really important to the organization.
Right. And the old-fashioned way of just talking to people and
absolutely
the business and know how things work. Right?
Yes, indeed.
definitely.
Yeah,
So
a friend of mine recently said that you have to be a corporate archaeologist in our business, to uncover all the things that are hidden and dig and find things and do the Indiana Jones, where's the valuable thing, because it's kind of hidden away. And I thought that was a good term. So you're going to be doing your Indiana Jones corporate archaeology hat in this process, and it will help everybody. There's a lot of mandates, like the U.S. government has a mandate that every organization knows what their high value assets are. And so that's a prescriptive thing. And I would think that you would want to know those things.
yes, absolutely. So we talked a little bit about sort of DAAS elements. Maybe let's dive into that a little bit. What are those sort of 4 categories of things, and then how do we sort of decide to grouping them together for the purposes of protecting at one time when they're related into a particular business information system or something? It might have different subsystems and those kind of that whole sort of trade-off, so you don't end up with too many and not too few either. Keeping things bite-sized.
Shruti, do you want to start off and we'll kind of have a conversation about that?
Sure, absolutely. So, well, it's sometimes it's easy to discover the data elements and the assets and everything, but then how do we actually apply the security controls in a way that makes sense to protect what is important? So that is where the business information system concept is what we have used in the paper is, group your related elements together. Sometimes there are services that actually service several product surfaces like your DNS server, DHCP server, Active Directory. Your favorite example, John, Active Directory, and then and another one of yours, NTP server. So probably they will form a product surface on their own, but in a cardholder data environment, I talk about cardholder data environment because I worked in PCI DSS environment, so it's one of my favorite examples. So we've got the application and then the database. So when application and database, they go together and they are in their own segment and they form a business information system. But at the same time, they are again protect surfaces on their own because application has its own requirements in terms of security controls and database has its own requirements in terms of security controls. Access controls are different. They are located in their own network segments. And then there are secure coding guidelines for applications. So that was how I saw it, John. I'm happy to know if my thoughts are aligned to yours in this respect.
Absolutely. I'm also a recovering QSA. So I say I'm in recovery because PCI is a 12-step program, and only people who've been doing PCI work will understand that joke. But the punchline is relevant because there are 12 steps in the PCI DSS, so that's why we call it a 12-step program. But it taught me how to focus on a single binary data string, the cardholder data, which we colloquially call PCI data, right? And it was easy to discover that because there's a mathematical formula called LUN formula or mod 10, you'll hear it either way. And so that you can analyze a packet and you can see, is there a live cardholder data or a live PAN, actually personal account number, in that packet. And so it was easy to discover. And then, inherent in PCI is that cardholder data environment should be segmented away from everything else. And so that really doing that in real time, and I was part of that first generation of QSAs that ever came out. It really informed my understanding of how to protect something that's like a single binary string, a data element, or ultimately an asset or a server. And sometimes, like you said, Shruti, this is not perfect. We're not trying to get perfection. It's trying to help us get a lens on things. So, DNS or Active Directory, yeah, that's an application. It's a data type. It's a server. There's always a server, but it's delivered as a service. So we tend to call DNS a service. But the things that accompany that in the flows are part of the protect surfaces, and you can have nested protect surfaces together or things that are coupled in policy in different ways. And there are shared services. So if you have a NAS or a SAN, yeah, they're storing data for multiple things. So they're going to be their own protect surfaces connected to different ones. But it's still a pretty simple way to look at it. And when I do whiteboarding exercises, it helps people understand this. But one big tip that I learned over time that will help people do this, we talk about designing from the inside out. So when I'm whiteboarding a zero trust environment, I do it left to right, step 1 through 5, and the protect surface goes on the left side of the whiteboard, where and then at least in English, and you read left to right, and typically we whiteboarded, we put the server or the laptop over on the left side, and at the top of the screen we put the cloud for the internet, and that's why we call that traffic east-west, right? Whoever on the first Visio diagram put the internet cloud up there, that became the convention. The traffic doesn't actually move east, west, or north, south. But if you start with the protect surface on the left side of the whiteboard and then follow it through to where you get to the resource accessing that protect surface, it will all make sense. So that's a simple tip to help you understand how to design this from the inside out.
That's very helpful. Thank you.
Yes, definitely. So as we're going through getting this understanding of what the different DAAS elements are and those key, the interfaces and the who the users are and supporting services and all of that, what are some of the other key metadata that we want to collect about that we want to understand to help sort of feed the subsequent steps ultimately in supporting developing a comprehensive zero trust architecture?
The first is the importance of the protect surface. And then the second one is what's the risk of it? Whether if the compromise of that protect surface results in a large time impact on the organization, or whether it's a small time. And also when we are acquiring the knowledge about metadata about protect surfaces, it's also important to know that there will be some protect surfaces or some DAAS elements that will be lying around, for which an organization knowledge or any kind of information may be lacking. And to what John said earlier on about, if someone pulls the plug, it might result in really a huge impact, but we don't know about it. So I think knowing what the elements are, where they are located, what's their importance relevant to the organization, what's the risk aspect of it, and also whether we know anything about it or not. I think these are all the key metadata that we would want to acquire when we are doing our discovery process.
And I think there's also a thing in the why statement in the policy, a lot of that is carved away so that ultimately we can track metadata when we ask why we do it. We do it because it's a cardholder data environment. So if you have a place to inject metadata into the stream, the PCI is the DAAS element. You can have, if you do automated classification, inject that into there as metadata. At my last job, we injected into the packet the compliance mandates that became, you could see that in a field that we call the why statement, about the compliance mandates are PCI and ISO and Sarbanes-Oxley and GDPR, whatever those things are, so that you can then analyze that data. The metadata is going to be useful when we're looking at the metadata to do advanced machine learning, artificial intelligence, to really analyze the data stream to make sure that we're stopping all the bad stuff and allowing all the good stuff to come through.
Excellent. And then, as we're collecting all this information about all the protect surfaces in the organization, looking ahead to the next steps where we're sort of iterating through on a per protect surface basis, what are the things we want to key on to help us decide which ones to go, first, second, and third? And do we want to jump right in on the most critical ones, or do we want to start simple and make sure we don't break anything, that kind of thing.
If I were implementing it, I would start with the simplest one. I would try out the process. I would try to understand how we can implement the zero trust principles, and then I would move on to a more complex one. I mean, there's nothing wrong in doing a complex one in the beginning, but then sometimes, it can have a psychological effect that, hey, maybe it doesn't work for us. So why get into that kind of a cycle? So start simple, ensure that it works for you, acquire learnings out of it, and then apply it to the next product surface. I would do it this way.
Well, and that's my guidance to people too. I have a thing called the zero trust learning curve. And that is where we look at the up-down access as the importance or the criticality of the protect surface, and the bottom, left-right axis as the time, and it creates a learning curve. And I actually built this and first drew it out in the Pentagon for the U.S. military. But the first set of protect surfaces we're going to do that Shruti is talking about are learning protect surfaces. I need to learn how to do it, and I do it in a system that has low criticality, so that if we make a mistake, hey, it's no big deal. And then I'll move up to something that's a little bit more critical, but still not mission critical. And those are practice protect surfaces. I got this term from my friend Tony Scott, who's the former CIO of the US federal government. Before that, he was the CIO of VMware and Microsoft and Disney. And he tells people you get to zero trust the same way you get to Carnegie Hall. Practice, practice, practice. And then after that, you'll focus on your high value assets, your keys to the kingdom, your crown jewels, whatever you call them. And then less important things will go in later, or as you build something up, you'll decide what its criticality is. And not everything needs to be protected in a zero trust manner. However you're protecting it, if it's a low system value or a low criticality, probably you're protecting it enough. I've seen people spend millions of dollars to protect, say, PDF documents in a marketing database that they were trying to give away for free. Now that makes no sense, right? And it wasn't like they were connected to some personally identifiable information. They were just a data store, and they were like, "Oh, we have to protect these PDFs." And I'm like, "Why? It needs some basic protection, but even if somebody steals them, you're trying to give them away." So it's not a big deal. So think about the value or the criticality or whatever, and ultimately that becomes the relevance. You're going to stack rank and say this is the most important thing. And one of the things is you're going to need to talk to different stakeholders about this. I remember talking to a hospital system, and the CISO said, "Well, my my PHI is contained in my EMR, electronic medical records. So that's my most important thing, because I don't want to have a data breach of my medical records, because then we'll get in trouble from HIPAA regulations and other things." And the CTO said, "Well, yeah, that's super important, but that's not our most mission critical system." And the CISO said, "Really?" And I said, "Really?" Because I thought the CISO was right on the nose, right? And the CTO said, "No, our most important system that we have, our most important technology system that we have is our elevators. Our elevators are all computer controlled. And if our elevators don't work, patients don't move. And if patients don't move, they die. So give me a choice between a data breach of our PHI, which is fines and fees and legal costs, and I can deal with that. I can't, if someone dies, they die. And I don't want that. So our most important thing is the elevator system." And that was a real revelation to me. And that only happened a couple of years ago. So every time I talk to people, I learn more about this, which is what I love about it, because you're never done learning. It's not static.
Yeah, excellent. And by extension, that would presumably also apply to other forms of operational technology, whether it's a dialysis machine or ventilators and things like that, because everything has technology components these days, right?
Well, if you think about the wireless pacemaker that Dick Cheney had, our former vice president, they replaced that with one that didn't have wireless control because they were worried about somebody hacking into it. Or infusion pumps that might pump morphine into a patient, they're wireless. I've worked on the security of that, and it was dismal. And from a movie plot scenario, you know, the next Godfather movie, when the Godfather's in the hospital, all you do is hack into the guest Wi-Fi, jump over into the hospital Wi-Fi, and find the infusion pump server and change the dosage and give him, you know, an overdose. And that's how hitmen work in you know, the sci-fi world, I guess.
Right.
So yeah, this is important stuff. And so, you know, we've actually seen some of these things a little bit in real life that have been documented.
Mm-hmm.
But you know, the manufacturers of various technologies tend not to give us very many security hooks. So we're going to have to figure out how to build around them. And so that starts with that protect surface concept, and then understanding how it works as a system. And when you see that, what's amazing when you look at a transaction flow map, you can say, oh, that's where I need to put the control, right?
Mm-hmm.
Whereas traditionally we learn to start by putting a control here and then figure out how everything else flows down from it. But if you start with the inside out and go, that's the important thing, then it will show you where the controls need to go. And it becomes very easy to architect it, which is why enterprise architects like Shruti have been the early adopters and the biggest fans of Zero Trust at the start of the whole thing.
Mm-hmm. Excellent. So you mentioned the Zero Trust learning curve. We do have that. You know, thanks for letting us include that in the document. And we talked about that in the sort of the whole prioritization exercise. And as I recall, when we looked at some of the demo screens that you had from your previous job with Onto It, we had that sort of Zero Trust dashboard. There was another element in there too, wasn't it? Sort of a secondary one. If you had, you know, 2 sets of crown jewels, there was another sort of security maturity element that factored into that.
Yeah, we were tracking the maturity based upon the relevance, and so the security maturity model. I've written about this on Cloud Security Alliance's website
Mm-hmm.
about how the original maturity model that I created at Forrester and refined, and it's in the NSTAC report, works with the CISA maturity model. So
Mm-hmm.
the CISA maturity model, we look at what are the technologies we're using inside the protect surface, but we're tracking the overall maturity of the organization on a per protect surface basis. So if I can look at protect surface 1 has a maturity of 10 and protect surface 2 has a maturity of 20, you know, the average is 15. But if I'm trying to do it all in the pillars and I say the identity pillar, well, I might have one portion where the identity is really great, you know, but in a big organization, if the rest of it isn't very good, the overall maturity averages out to close to 0. So that's why you want to look at it on a protect surface basis, because you have insight into how we're doing in this area, right? And you do that same thing like when you're renovating your house. You do it one room at a time, right? If you think about it, unless you know, you're on one of those TV shows where you can bring in 300 people and they can renovate it in 48 hours, you know, you can't afford to do it that way. So you start with whatever is the most important. I'm doing a new house now. So we're starting by ripping out carpet and putting in some, you know, laminate hardwood floors. And so that's step 1. And the thing we're working on is just this one part of the house. And we're not trying to redo it all at the same time. And I think that that's how you do things normally and logically. But we tend to think of security and networking as one big thing, and it's not. It's a collection of small subsystems.
True. But we've had some interesting conversations coming up, particularly when we look in the subsequent steps, step 2, step 3, that, you know, isn't there or aren't there also cases where you want to sort of zoom out a little bit and look also more holistically at, say, are there some core services, like, say, we need a new HVAC system for the whole house because our furnace is old and still burning oil and that kind of stuff, where you may want to focus in on creating some, you know, centralized services like that that can be used by all the protect surfaces.
Absolutely. A great example is DNS.
Mm-hmm.
So if you think about, you know, you say, well, this is my web server, and I'm going to put, I'm going to segment it away, and, you know, only open 80 and 443, or, you know,
Right.
whatever our ports are, and blah, blah, blah. Well, you're also going to have to open up DNS. everything has to use DNS. Almost everything has to use NTP. So those services become hypercritical. That's why in the NSTAC report, we chose Active Directory as our example protect surface, because it's the one thing that everybody has. Everybody has some sort of directory service. And I would say it's been a long time since I've seen someone who doesn't have AD as their centralized identity store. So, I mean, there are ones out there, don't get me wrong. So if you're a vendor of that, I'm not saying anything, negative. It's just in terms of commonality, that is something that is nearly ubiquitous, especially in big organizations. And so you look at that and you start to understand, well, I've got these two protect surfaces that are interacting as part of a larger information system, as Shruti said.
Yeah, and Shruti, isn't that one of the examples that came up too? Is like, if you're going to look at implementing some enterprise services that are reusable identity related services, is certainly one of those. Another one that came up is, SIM systems. It's like, would you have a separate SIM for every environment that collects the log information and that sort of thing?
Absolutely. And we also talked about the service discovery, for which DNS again comes into picture, because without service discovery, its assets don't talk to each other. So yes, there will be some kind of shared services in enterprise organizations.
Right.
I did this once for smart meters, a massive deployment of smart meters. And what I found was smart meters are not very smart, right? And you can't actually put host-based controls on them. At least at that time you couldn't. And as we were analyzing, what could happen to the system, and this was before the Mirai botnet, we realized, what if the smart meters start attacking the system, right? The energy system that is being metered here. And so the protect surface became the management system that controlled the smart meters and took data from the smart meters, not the individual smart meters themselves. There were so many of them, and there was very limited things we could do. Let's put the micro perimeter and segment away the management servers and the management system, so that they're protected from attacks by anybody, but especially the smart meters.
There's also the other example, John, about the Florida water treatment plant. So the actual attack surface was TeamViewer application on the server that actually allowed connections to monitor, to change the fluoride levels in water. So what had to be done was the TeamViewer had to be either restricted from the internet or locked down from an access control perspective. Only the right authorized person could access it. So that there is that example as well.
Yeah, if you can find your assets on Shodan, that means they're part of a protect surface, and you need to lock that down, right? So
Indeed.
Definitely. So to recap, step one is you're developing this inventory of all the different protect surfaces in the environment and collecting some metadata, coming out of that with prioritization, which are your practice environments, which are your high priority ones based on their criticality and maturity and that kind of stuff. And then so you're launching into step two now for with the ones you've selected, whether it's a practice or a more critical one. But so maybe let's talk a little bit about looking forward to the next steps. And John mentioned that it's a lot about understanding how the system works, so you know what the control points are and stuff. So let's maybe dive into that a little bit further.
Yeah, the one thing I would say about that is sometimes you'll know that the protect surface, I know conceptually I want to protect PCI data for credit card information, but if you don't know where that is, then step two gives you insight into where that is and how that works. So step one and step two are kind of highly interrelated, and often they're parallel streams to each other, right? But you kind of, in terms of codifying it in a document or a presentation or a thought pattern, you have to decide which comes first, right? And you have to, a lot of times though, through step two of mapping the transaction flows, you'll discover a protect surface that you didn't know you actually had. So it goes back the other way. And so it becomes, it's not a perfect linear thing because, again, it's anti-fragile. So the process of data flow mapping or transaction flow mapping, like I've always called for, and which the NSA calls for, gives you insight into other things that you probably didn't know about because you didn't have the institutional knowledge. There's nobody at the company who was around when system X was put in and it's been functioning fine. And you go, oh, but I didn't know this was here. And this is maybe hypercritical, right, as a service. And so that kind of thing happens all the time. So you're trying to get visibility through step 2 that gives you insight into step 1 and step 3, both at the same time.
So yeah, that's what we started calling the concept of progressive elaboration through the different steps, that you're sort of diving in, you're learning stuff, you're making adjustments, refining your information, refining your approach. It may even trigger reprioritization if it's like, oh, maybe we should do that first, kind of thing. Right.
There were a lot of syllables in that sentence, Eric. That was very impressive.
Right. Sure. Do you remember some of those conversations we had in different use cases we looked at?
Yes, actually. One again, going back to the elements that do not have any organizational knowledge. We talked about how. And I have a good example for this. I don't want to take any names because I still owe allegiance to the companies I worked for. We used to have a server, a Windows machine, 1995 Windows machine, which built an application. And without that machine, the application couldn't be built. It was a desktop application. So once, I think when someone tried to power it down, it was powered down. And then when someone wanted to build that application, they couldn't find it. So there was this little bit of a turmoil in locating that server. So yes, so when we do the transaction mapping and the next steps and all that, so we identify such assets and then we build upon our knowledge of the key metadata and also how they connect with the application, so that server can be connected to the desktop application that is deployed on the user's machines. Yes, these were I think that's a very interesting discovery point, both together, step 1 and step 2.
Right. And are there any sort of common applications or software that people use to collect all this information about their protect surfaces and the information flows and things like that? I mean, the sort of asset management and data flow mappings and things aren't really that new, so there have to be some tools out there, aren't there?
I would think asset management databases would help, but it might require some customization because every organization sees it differently. It's not a standard; it's a framework, and it's a principle and philosophy. So yes, I mean, I'm very sure there will be tools that can help us expedite the process, but it might need to be customized to the relevant environment.
Gotcha. John, do you see any particular patterns? Have you come across any particular tools that are in common usage?
Well, yes, but I think that's a little self-serving given the hat that I'm wearing today. So,
okay.
but there are a lot of different ways that everybody's trying to automate it, and we're trying to create CMDBs, change management databases, and there's different ways, different visibility tools and other things that you can use. So yeah, and I mean, again, this is something that everybody, what we hear about AI and ML, and I know we have another work stream going around that, and my friend Troy over there and Caleb are working on it. Both people I've known for a long time. So that's exciting. But the real value of that isn't, everybody else is worried about the attackers are going to be able to make new attacks, but the defenders are going to be able to automate defense. So, in the movie The Imitation Game, about Alan Turing building the Bomba, the analog computer that broke the Nazi Enigma codes, At one point, the character in that movie says, and you should go watch that movie from a cybersecurity perspective, just to really get some inspiration. But at one point, the character of Alan Turing says, "What if only a machine can defeat another machine?" And our adversaries are highly automated, right? But we aren't. We still have a lot of manual processes, a lot of change control, a lot of manual things, a lot of phone calls, a lot of webinars to make simple decisions. And ultimately, those things have to be automated if we're going to keep up with the speed of the threats. And I believe that we can do that. I mean, my previous company, I worked at a place where we had no level 1 or level 2 SOC engineers. It was all level 3 because the machine itself took care of what used to be looked at by a human being at the what we would call a level 1 or level 2 stage. And so this is the real hope and benefit and aspiration of AI, ML, generative AI. There's 1,000 different terms to talk about it, but it's using data to speed up decision making and automate the process so that human beings don't have to become involved. And we've done this in various ways, right? I mean, when I was a kid, there were phone operators. This is how old I am. So you could, especially if you had to make a long distance call, you had to pick up the call and ask for an operator, and then they would physically patch you into it, or they would maybe electronically patch you into it. But we automated that process through phone numbers, right? The first 3 numbers mean something, and the second 3 numbers mean something, and then the last 4 numbers mean something. And it's an automated process that used to be done manually. Same with airbags, right? You couldn't manually deploy an airbag, but an airbag has sensors that detect things and automatically deploys. And most of the time, it does it at the right time and saves your life. And occasionally, you'll hear about an airbag that went off at the wrong time. And so, but we don't go, well, let's take out our airbags because one misfired. But that's what we do in cybersecurity. As we automate things, if something goes wrong, get rid of that system, make humans be involved so we don't make any mistakes. Look, folks, we're never going to not make mistakes. This is too complicated of a system. But at the same time, the more it's automated, the less likely the mistakes that are made are devastating. And it's that manual process that leads to data breaches and significant cybersecurity incidents.
Right. And that's where the whole iterative incremental approach allows us to take things in bite-sized chunks and to make corrections as we go, limit the blast radius if anything does go wrong, right? And not to mention the zero trust principles around microsegmentation to limit blast radius of impacts, which is a different conversation. But so in conclusion, the whole, the 5-step method and the importance of step 1 about getting visibility into your assets and what's important and what is your current state environment to help you prioritize. Maybe just sort of some closing thoughts you might want to offer, both of you.
Let's start with Shruti.
I think we should start the journey. As journey of any journey begins with 1 step. I would encourage people to start on their zero trust journeys. At least think about it. Try to do 1 protect surface, and you will say it is not complex at all. You just need to get into the groove. So I would just say start your journey.
Yeah, I was going to say the same thing. I have one client who said we argued about zero trust for more time than it took us to deploy our first protect surface. So just get going. There's no excuses anymore. People want to argue about what it is. That's pretty well defined in the NSTAC report and in what we're doing here at CSA. And what's exciting about CSA is CSA takes a collaborative global approach to this issue. So there's a lot of other guidance that are specific to certain things, especially related to the US federal government. But we have a lot of stakeholders around the world, right? So this year I'll do a number of different events with CSA in different parts of the world, not here in the United States. So the fact that we're global, right? Shruti's in London, I'm in Dallas. And so the fact that Cloud Security Alliance is a global organization just helps us become more collaborative and really solve these problems for all of us.
Yes, definitely. And we've got a large number of people engaged in this working group and new people signing up all the time, new organizations that are joining us, and the interest continues to be really strong in zero trust, and it's exciting to see the number of different use cases and the level of adoption, and even with all the sort of the buzz and interest in AI today, like you mentioned some of the key points about, it's like, do I do this or that? How AI can help with the implementation, operation of secure environments, and just as zero trust can help secure AI environments and customer data in there. So,
and I just want to say how humbled, honored, and thankful I am to you, Eric, to Eileen, and to Jim, the whole Cloud Security Alliance, to see the enthusiasm of Shruti and all the other people. There's hundreds of people who've been involved in this. I don't know exactly how many, but sometimes the calls are so large, and to hear that enthusiasm, for me, being a lonely voice in the wilderness for a long time, is very, very humbling. So thank you so much, Cloud Security Alliance. Thank you, Eric, especially for herding all of us, herding cats. You are the preeminent cat herder out there. So thank you. And thank you, Shruti, for leading this work stream.
Yeah, thank you. And I agree. It's definitely heartening to see how all of your evangelizing over the years has actually come to fruition. I can just imagine, how rewarding that is. But
thank you.
Thank you, John. And thank you, Shruti.
Oh, I would also like to thank, actually, I'm really very proud of being associated with the Cloud Security Alliance. Otherwise, I wouldn't get to meet you, John. I wouldn't get to meet you, Eric,
Right.
and get to work on all such amazing topics. So yeah, my thanks, heartfelt thanks.
Yes. Thanks, everybody. And thanks for joining us for this, the first of the series of guidance events. Do check out the documents on the website and the slide deck we have to go with it, the defining the Zero Trust Protect surface, and look for the materials coming forward over the rest of the year on the other 4 steps. So thank you all, and have
Hey, and before we go, don't forget the CCZT training stuff.
Good point.
This is important. If you want to learn more, there's training out there, there's certification.
Yes.
And the only thing that I have a certification in currently that's up to date is CCZP. So I believe in it. I helped create it, of course. So I do believe in it, but I'm very thankful again for the Cloud Security Alliance for doing that, because I think that this just changes the dynamic.
Yes. Yeah, thanks for that reminder, John. The CCZT training and certification. In fact, we just released the 7th module today on Zero Trust, the Zero Trust Strategy module, and there'll be more to come as we go forward.
Great.
So yeah, it's all available on cloudsecurityalliance.org. Check out the materials, and talk to you all soon. Thank you.
Thank you.
Thank you.